Let's go from here. So we began the for loop the other time. We talked about the while loop. We talked about the do while, I think. So now we actually began to discuss the for. So today we will wrap up our discussion on the for loop. So since the first, by the way, if you are getting distracted, please find a way not to get distracted. This part of for loop is complicated, it's confusing. So please do not get distracted this time. Since the first and third expression in the first statement are executed as statements, their values are irrelevant. They are useful only for their side effect. So the point is this: if you say for I, let's see if I can place an editor on the screen, I can type in. Yes. So if we say for I is equal to 0, I is less than 10, increment I. Now, what does this mean? Initially, we discussed that the first part of this expression, we said the first part of this expression is evaluated only once. The first time we get into this loop, let's say here we do something. So the first time we make use of this for loop, we evaluate the value of I. So we set I is equal to 0, and this will be the last time we will ever evaluate the expression 1. This is expression 1, this is expression 2, this is expression 3. So the first time we evaluate the value of I as 0 would be the first and the last time we will evaluate expression 1. So in subsequent runs, we will always evaluate expression 2 and we will evaluate expression 3. But here we are being told that since the first and third expressions in the first statement are just statements, their values are irrelevant. They are useful only for their side effects. So if you have some value, some things you want to do with I in this code, okay, you can make use of it. But this is the most critical part because you need a stopping condition. If you don't have a stopping condition, then you most probably will end up in an infinite loop, except you have a way to break out. So these two expressions are usually assignment statements or increment slash decrement. It could be decrement also. So usually these expressions are increment slash decrement. So we discussed the number of examples. We said we can set I to be 0 and then we increment till it gets to n. So this way we will step n times because we are increasing by 1. So we start at 0, we stop at n minus 1. And since we are starting at 0, we will have n steps. For the second one, we are starting at 1, not 0. We are starting at 1, but we are stopping at n. Observe that we have equal to also. Here we have only less than, but here we have less than or equal to n. So at this point, we need to understand the difference between this and this. We are going n times here. We will go n times here also. For both situations, we will go n times, we will go n times. But the difference is that here we will go from 0 to n minus 1. Why? Because we will stop at less than n. So we will never get to n. But here we will go from 1 to n because we will include n. This says also we can include n. So in the opposite direction, we can start from n minus 1 and stop at 0, or we can start at n itself and stop at 0 plus 1. The I must be greater than 0. So okay, we discussed this. We discussed off by 1. So we continue with this. Common for statement error. There are times that students make mistake and they use less instead of greater. If you use less instead of greater, you most probably will have an infinite loop because the value that you'd reduce keeps increasing while the stopping condition expects a reduction. Let's try something like that. Include this to be idle.h. Okay, so we can say, okay, so we can just use this as an example. Let's see to compile. Where do I save? All right. So we can save here as new day. Yes, it's a new day and we will write new code. Okay, it says, okay. This is a practice that is allowed in. Okay, we forgot to go to the next line. Let's go to the next line now, print. Now, so what do we have? We start I from you should close. We start I from 0. So currently I is equal to 0 and we print the value of I. We increment after the body of the for loop and then it becomes 1. We increment again, it becomes 2. When it gets to 9, we increment again. But after incrementing, we cannot come back into the for loop. So it stops at 9. But we can make a mistake. We can say I minus minus. So what would happen? It will start from I is equal to 0. Expect to stop at I is less than 10. But the problem is we will never get to I is less than 10. I mean, we always stay at I is less than 10 because currently I is 0. 0 is less than 10. But if we change this to minus minus, I will always be less than 10. So this expression will always be true. And because of that, we get stuck in an infinite loop. Let's try that again. Let's close this and try that again. All right. So what's going on? We are going the opposite direction of the stopping criteria. And because of that, our code will never stop. It will become an infinite loop. Somehow we have to either close it or force it to stop execution. So this is the significance of using the appropriate sign. If you make a mistake in the sign, you will have an infinite loop. All right. So here we count up loops and we must make sure we count down loops at the right time. Also, you cannot afford to use the assignment or the equality operator. This would create some problem for your code. Also, we have one-off error where you use I is less than or equal to n instead of I is less than n. So you should be careful of this. We discussed this last time, I think. Okay, so C allows any or all of the expressions that control a for statement to be omitted. So what it means is this: you can have the initialization removed from the for loop. So the expression one has been removed from here. Why? Expression one is just a statement. We said it earlier. It's just a statement needed for its side effect. So we have created the side effect before getting to the loop. This is the side effect. This is the side effect. So we have created this before getting into the loop. And because of that, we don't have any problem. The code will work. So I is equal to 10. What just happens is it checks, is 10 greater than 0? Yes. It prints the value here and then it subtracts 1 from 10. So it becomes 9. Also, the third expression can be removed. What does this mean? It means that somehow you must find a way. This is important. Somehow you must find a way to change the value to either increment or decrement. So observe what was done in this example. Even though they removed the third part of the expression, they found a way to solve the situation by decrementing in the print statement. So they moved it from here and decremented in the print statement. So now you can see that we can remove the first, we can remove the last. So actually we can set a for loop to be something like this. Where is my text environment? Yes. So I can change this for loop to, let me add a print statement here, print f I is so I can move this. So I can remove this. And again, I can move this. And this will work. Why? Because the starting expression has been defined here. The increment of the high is done here. And so the code will work. Now, one important thing I need you to observe is that for every of the expressions that we removed, we did not remove their semicolon. This is really important. We did not remove their semicolon. Observe that here, even though we remove what was meant to be here, we still put a semicolon to pretend as if there is something there. Yes, there is something there. It is just an empty expression. So we have to show that there's an empty expression there, because this is the structure of for loop. For loop expects to have 3 items in the parentheses. So we must put 3 items. And again, for this third expression, we have, come on, yes, we have the space for the third expression, which is denoted by the semicolon. So please do not forget this. So when you omit the first and the last, just like we did in the previous example I wrote in the text editor, it just looks almost like a while loop, because this is just what a while loop looks like. Aha. Okay. Now we have not touched this part. Why? Because this is the stopping criteria. If you remove this part, then you must find a way to stop the code. You must find another way. There are other ways. You can use the break keyword. But at this point, it's better to say It is possible to remove this, but don't remove it if you don't know how to remove it, or if you don't know how to make a replacement for it. All right. The second expression, if the second expression is missing, it defaults to a true value. So the for statement doesn't terminate unless stopped in some other way. So here is an example. If you want a for loop to always keep executing, you can have the parentheses empty, just denoted as the parentheses of a for loop by the normal number of semicolons, the comma operator. On occasion, a for statement may need to have two or more initialization expressions, or one that increments several variables each time through the loop. This effect can be accomplished by using a comma expression as the first or third expression in the for statement. So here is what it means. We can have I is equal to 0. We can have j is equal to 5. So we can say while I is less than 6, I plus plus j minus minus. What are we doing? We are changing two variables at the same time. We are changing the value of we are setting I to be 0, we are setting j to be 5. So with this increment, we are increasing I from 0 to 1 to 2 to 3 to 4 and to 5. But at the same time, this is important, not after. At the same time, this is for I. At the same time for j, we are having the opposite: 5, 4, 3, 2, 1, 0, 0. And this is for j. So at the same time, we can change two variables in a for loop. Okay. A comma expression is evaluated in two steps. Expression one is evaluated and its value is thrown away. We don't need the value of expression one. I already told to you that we only want to assign the value to expression one and then we forget about it. Expression two is evaluated. Its value is the value of the entire expression. So what is the value of the entire expression? Let's bring our code back. So expression one is evaluated and thrown away. Then the value of the entire for loop is the value of expression 2. What is expression 2? Is I less than 6? If this is true, the answer is going to be 1. So the value of the for loop is 1, though that is not going to be the value of I. The value of I is whatsoever value you set here. The value of j is whatsoever value you set here. But the functional value of this entire for loop is true. This is the important thing. The functional value of, let me just stop here, of this for expression is true. This is the meaning. So it means we are saying for true. And by the way, I believe that you still keep in your mind that we don't have true in C. I only said true so that your mind can take it as a logical expression. So the answer is true, which in C is mapped as non-zero, 1. Okay, so evaluating expression 1 should always have a side effect. If it does not have a side effect, then expression 1 serves no purpose. When the comma expression plus plus I plus j is evaluated, I is first incremented, then I plus j is evaluated. So here is the idea. If you have such an expression, we first increment I, and then we do the addition of I and j. If I and j have the values 1 and 5 respectively, so I is 1, j is 5, the value of the expression I plus I and I plus j is going to be 7. Why? Because we said this will evaluate first. When this evaluates first, plus I evaluates, it is 1 plus 1, so this becomes 2. I becomes 2. So at I plus j, I is no longer 1, I is now 2, while j still remains 5, and this gives us 7. The comma operator is left associative, so the compiler interprets this as this first. The comma operator is left associative. Please keep this in your mind. The compiler evaluates what is on the left of the comma operator before it evaluates the next expression that thing is in. This is important. So it first sets I is equal to 1, and then it sets j is equal to 2. By the time it gets to k is equal to I plus j, it is making use of the value in I and the value in j. So since the left operand in a comma expression is evaluated before the right operand, the assignment this will be performed from left to right. So because of this comma operator, it makes it easy for us to stick too many expressions together. So the comma operator makes it possible to glue two expressions together to form one single expression. Certain macro definitions can benefit from comma operator. The first statement is the only other place where the comma operator is likely to be found. So you can find the comma operator in the for loop, and also you can find it in macros. I hope you remember macros, definition of constants in C. You can find it in constant definition. With additional commas, the first statement could initialize more than two variables. So you could have another comma here, some expression, another comma, some expression, and so on. Okay, we are looking at a program now. It's called Square Program. It's used to convert some values into their square. Okay, it prints a table of square. We are familiar with this. I think we did this the other time. We did this the other time. Exiting from a loop. The normal exit point of a for loop is at the beginning. Why? While it is testing. Look at our for loop again. Our for loop always tests. It comes back here to test if I is less than 6. So that means whenever this for loop is going to terminate, it's going to terminate when it is evaluating this beginning expression. So that is why we say for loops always terminate at the beginning. They start at the beginning and they terminate at the beginning, as in a while or a for statement. But on the other hand, the do statement terminates at the end. Why? Because the do statement will test at the end. So here is what the while equivalent of this expression will be. It's going to be I is equal to 0 while I is less than 6. Let's bring the printf. Oh, by the way, I didn't close the expression. Okay, so we close the expression. This is the equivalent of the same for loop in this for loop in while. Here I'm assuming that I have declared I as an integer. So we are just using the value of I. This for loop and this while loop are the same thing. Okay, let's move forward. Okay, we already have increment and decrement here. We don't need to increment again. By the way, if we leave the increment there, the code will still work. Yes, so, but just for cleanness sake, let's remove it from here. Okay, so this is the while equivalent. But on the other hand, we have the do. Okay, so this is the for loop. This is the while loop of the same thing. And this is the do while loop of the same thing. So observe, in the do while loop, we test at the end of the loop. And this is why we say that the do while loop terminates at this point. Terminate at this point. It terminates at the exit. So the do while terminates at the end. The while and for terminate at the beginning. But with break statements, I would rather say break keyword because it's just a keyword. But with the break keyword, it's important to write a loop with an exit option elsewhere. So we can break elsewhere. Here is an example. Let me change this code that we have so that it can break elsewhere. Let's remove the do while and stick to the for loop. Okay, so I can print this and I can say, so this way we can jump out of the entire for loop whenever the value of I is 4. So whenever the value of I is 4, we break the code and we jump out of it. So the break statement can transfer control out of a switch. It can transfer control out of a while. It can transfer control out of a do while. It can transfer control out of a for loop. So it can transfer control out of all of this, the break statement. So here is an example of the usage. I already showed to you in that text editor, but it's about the same thing. So we enter the for loop and then we decide when we want to break. We say if some condition is met, we say if some condition is met, then break. So after the loop was terminated, an if statement can be used to determine whether termination was premature. Hence, n isn't prime or normal. N is prime. So here is an example. We can say if d is less than n, then print that d is divisible by, okay, then if d is less than n, print that the first placeholder, which is n, is divisible by the second placeholder variable, which is d. So if d is less than n, then certainly n is divisible by d. Else, print d is a prime number. I mean, this will be after the for loop. This will be after the for loop. Because observe, we are trying to see if n mod d is 0. Any question? Okay, the break statement. The break statement is particularly useful for writing loops in which the exit point is in the middle of the body rather than at the beginning in while and for, or at the end in do while. Here is an example. Here is a loop that reads user input and it stops only when the user enters a specific value. So let's say you want to keep reading a user input, and anytime the user types 0, you want to stop reading. This is difficult to predict because you are using a for loop. Okay, it's easier to do if you're using a while, but if you're using a for loop, it's difficult to do because for loops requires a counter. You cannot predict when the person will press 0. So you cannot say, I know it will press 0 after 5 times. So 4 will go 5 times. You cannot do that. And because you cannot do that, you have to set it as an infinite loop because you don't know when it will stop the code. But you have to use a condition to exit the for loop. And that is this. A break statement transfers control out of the innermost enclosing while, do, for, or switch. This is important. So observe, we said that break can take us out of while. This is while. It can take us out of do while. It can take us out of for. It can take us out of switch. Let's change colors. Okay, we said it can take us out of switch also. And this is switch. So here comes the question. Now we have a break inside of switch. What will the break do? The answer is that the break will take us only out of the switch. It will take us only out of the nearest braces that is around it. The nearest brace. This is important. It takes us out of only the nearest brace. Probably we change colors. Let's find what color can we use. Let's use purple. So the break would only break us out of the switch. So break transfers control out of the switch statement, but we are still going to remain in the while. We will be out of the switch, but we will still be in the while. All right. So again, before we continue before we go to continue, let me remind you something very important about the break, so that you don't get confused at continue. Now, where does break take us to? Break us take us outside of these curly braces, outside of these curly braces, but continue will take us just before the curly braces. This is where continue will take us to. With break, let's assume after break, we still have, let's say, 10 lines of code. Break helps us to jump those 10 lines of code and also jump out of the while statement completely. It helps us to jump out of the lines of code and out of the while statement completely. But continue will help us to jump out of the 10 lines of code, but we will not come out of the while. I'm out of the switch. I mean, out of the switch. I wanted to say switch. So break helps us to jump out of these 10 lines of code and out of the switch. So we come outside of the switch and then we continue the next while. But continue will not take us out of the switch. It would only take us to the end of the switch, such that the code will normally move to the next line by itself. Okay. The continue statement is similar to break. Difference: break transfers the control out of the end of the loop. So observe, break takes us out of the nearest curly braces. This is just the simple way to explain things. It takes us out of the next curly braces. But continue transfers control to a point, just okay, let's say here is where break will take us to. Continue transfers control just to a point just before the end of the loop. So this is what continue does. It transfer control to the last statement before the end of the loop. With break, control leaves the loop, but using continue, control remains inside the loop, inside. So there's another difference between break and continue. Break can be used in switch statements and loops, whereas continue is limited to loops. I think I don't need to explain this. It makes sense. Because actually, while I was explaining, that was why I paused here when I was saying continue. Because I realized, okay, if we use continue and we come here, what is the point? It is useless because nobody can continue a switch. The moment you already pick a situation in the switch, you don't go back up again. So continue is useless in switch. Continue is only useful in a situation where you can go back and continue. So we don't use continue in switch statements. We use continue in iterations. Remember, switch is selection. Switch is selection. But these other guys, these guys are for iteration, iterative structures. Okay, so here there's a loop that uses continue. So we have the while, and inside of the while we say whenever I becomes becomes zero, continue. So what does that mean? It says whenever I becomes zero, don't try to add zero to sum because we know that it does not make sense mathematically. It's just a waste of CPU. So here is what we will do. Whenever I is zero, just continue by jumping this way. Jump to the end of the curly braces, but don't exit the curly braces. So jump to the end of the while loop and let n move to the next value. So n will change to n plus 1. So here is the same loop without continue. If I is not equal to 0, do the sum. Whenever I is equal to 0, don't do the sum. Okay, so you can write it without using continue. Go to. Go to is another keyword that we have in C, though we don't have it in many other languages, especially Java. Java stopped it when Java was introduced. So go to statement allows us to jump to a specific part of the code. So with the go to statement, we can jump to any statement in our code, any statement in a function, provided that the statement has a label. So this label is like the name of that group of code. So here is the idea. We say identifier and then the statement. This is how to build the label. So normally we can say John And then I can use curly braces if I have many lines. I can use curly braces. So I can jump to this place based on a condition. A statement may have more than one labels. So the go-to statement itself has the form go to and then this label. So here is the idea. I can be in an if statement and I say, let's say if A is greater than B, go to, oh, that's a very bad go to. So go to John. By the way, it's a regular statement, so it must end with a semicolon. Yes. So what happens is if this expression is true, we go to this next line and the go to jumps us to wherever this label and its statements are. So executing the statement, go to hell. Transfer control to the statement that follows the label L, which must be in the same function as the go-to statement itself. This is important. Must be in the same function as the go-to statement itself. This is really important. Keep this in your mind in coding. Keep this in your mind also for the exam. You cannot jump out of a function to another function. You must only jump within the same function because functions can only be called. We don't jump into them. If C didn't have a break statement, go to statement could be used to exit from a for loop. Okay, from a loop, we know that we can just create an empty block and say jump to the place. So, or we can move the next part of the code and name it done. All right. So the go-to statement is really needed in C programming. We don't always use it because there are other constructs for writing quality programs. So the break, continue, return statements, which are restricted goto, and also the exit function are sufficient to handle almost all the situations that we might come across in the C programming language. Goto is available, but not always used. Consider the problem of exiting a loop from within a switch statement. So the break statement doesn't have the desired effect. It exits from the switch, but not from the loop. Okay, so let's assume we are doing something, we have a while, and then in the switch, we have a critical condition. So in the switch, we say, if you ever encounter this problem, don't continue in the while loop anymore because we already have an emergency situation. Break cannot take you out of this while loop. Why? Because break takes us out only out of one curly braces. It can't take us out of the two. So how do we solve this? We can make use of a quality go-to statement. Let me write an example for you so you can easily grasp this. So here is what we have. Let's say while um, engine is greater than zero. So we assume that engine is greater than zero means the engine is working. So we can say switch um, emergency. So we are switching based on the emergency situation of the car. So we can say case zero. So we assume that case zero means there is no emergency. Um, keep working. Okay, break. I'm just trying to put the syntax so you keep in your mind how the case works. So we have case one, So let's assume that case one means there's a light, but we think it's just a minor thing. Um, Stay cautious. Stay cautious. So look around, be very careful. Make sure that there's nothing that can be damaged. Just keep watching the behavior of the engine. And then we can have case two, which is a case that means that we are really about to have a problem. Okay, I think I skipped to put the curly braces and then this. Now, here is what we have at the end of the day. We have the while statement evaluates the state of the engine. It switches based on an emergency signal. So, if there is no emergency signal, the engine keeps working and we break out of the case. We break out of the switch completely. So we keep checking, as long as the engine is on, we keep checking the emergency situation by switching several times. Let's assume that emergency situation can change. After some time, emergency value changes to 1. So we just come here, we tell the user, please be very careful. It seems there is something going on with the engine. Not yet bad, but just be careful. Let's say after 10 seconds, it changes back to 0. Then we say, okay, keep working. But after some time, it changes to 2. And then it gets to, oh, stop. The engine is going to have a problem very soon. And we try to stop the engine, but we cannot. Why? Because the brake only takes us out of the switch. So it means it takes us out of the switch, puts us in the while, and the while returns us back into the switch again. So we will only see stop until the engine gets damaged. So how can we actually stop if we really want to stop? We can use the go to. So uh, we can create um we can create a go-to block, a block we want to go to in case of emergency. So here is the idea. We can create a block of code called emergency, or whatever name we want to call it. Our only target is to use it to save our engine. So how do we use it to save the car engine? We remove brake because we know brake cannot help us. And instead of brake, we use go to emergency. So whenever we get into this dangerous case, we don't use brake because we know brake won't take us out of this while loop. So we use something that can take us completely out of any part of code to another part of code. So it jumps from here and looks for a block of code called go to. It comes here, and so we stop the engine. This is really important about the go to statement. Even though it's not widely used, it's really important. It's really important. Okay, null statement. Accidentally putting a semicolon after the parenthesis in an if, while, or for statement would create a null statement. So if you put this here, it will create a null statement. I told this to you earlier. So in for, in if, in while, you would observe that there is nothing after the parentheses. We make sure that there is nothing, there is no semicolon. Don't put a semicolon. Semicolon would make the code to do nothing. So it would make the code not to enter into the other part. So if I put a semicolon here and I run this code, nothing will happen. Why? Because whenever the engine is on and the value is greater than 0, it executes what is between the curly braces and this semicolon, which is nothing. So it does nothing and then it goes back. So we will never evaluate this part, never. Because this part is inside of these curly braces. So this part actually is the statement to the while. If you put a semicolon before that statement, then you have created a new statement, which is nothing. So please be careful about this. All right. Okay, so let's see what is next so we can decide if we will continue or maybe we will stop. Let's see. Um, I'm trying to check the course outline to see what we should be doing now and what we are doing now. Ah, we still have a number of things to do. Okay, but the things we need to do are not that many. Majorly, we will not focus on doing file operation and strings because um, I put them there just in case we can do them. But we will do data types, we'll do arrays, and then we'll do functions. So we have 3 topics. I believe we can finish the 3 topics in our next 3 classes. So let's look at data types for 1 minute before we stop. Let's look at data types. Okay, so let's look at data types. I know you may probably want a break, but we we just discuss data types for 1 minute and basic types, and then we stop. Okay, so basic types. What are types? We know types. Types are integer, float, double, and so on. So we just want to have a discussion on these types. Six basic built-in types. We know integers, we know floating point, we know a number of others. Just a moment, it seems I cannot write. Okay, we have integers, we have floats, and we have char. These are built-in types. In other programming languages, we call these the primitive types. In fact, it is just a general programming construct. These are called primitive in programming languages. These are the primitive types. Other types are called reference types because other types are reference to these primitive types. So other types like array, which we will talk about very soon, are called reference type. I just have to remove this C again. Okay, I have a replacement already. Yes. So we have integers. Though you are familiar with integers, we have different types of integers. That is something you probably may not be familiar with. We have different types of integers. And I introduced to you that we have long, we have short, we have signed, and we have unsigned integers. So signed integers are integers that can be -5. Those are signed integers. So whenever you put a sign in front of an integer, it is not a regular integer, it is a signed integer. But generally, when you write int, it is an unsigned integer. If you write int x, it is an unsigned integer. So floating point also, we have different floating points. We have the regular float, we have the double float, which is longer than float, and then we have the long double float, which is longer than double. So this is just the idea. Because we want precision, we can try to make the number of 0.00000567 to be larger. So this has this amount of precision, while double has this amount of precision, and long double has point larger. This is just the idea. After the decimal point, the number of digits that can be accommodated is increasing from left to right in these three types. And also we have the char. The char is one character. The char is the foundation of strings. So if you have something like John, first thing is that John is a string. John is a reference type, not a primitive type. And also, John is a group of 4 chars. J is a char, a character. O is a character. H is a character. N is a character. So each one of them are characters. When somehow you need to bring all of them together, then you are somehow creating a string. And that is, you're making reference to many chars. That's why we call them reference type, because they bring together many primitive types. Okay, C supports two fundamentally different kinds of numeric types. So we have the integer type and we have the floating point type. These are the two types, the numeric types that we have in C: integer and floating point. Integer and floating point. These are the two types that we have in C. So under the integer part, we have the normal integer, the signed and the unsigned. And under the signed and unsigned, we have the normal integer, we have the long integer, we have the short integer, and like that. Under the floating point type, we have the float, we have double, we have long double. Okay, values of an integer type are whole numbers. You already know this. Value of floating point have decimal points. You already know this. The integer types in turn are divided into two types, which are signed and unsigned. Okay, if you didn't know before, I already told you here. We have signed and unsigned. All right. So I think because of the complication of this part, it's not so difficult, but it's just a little bit confusing. I will ask that we stop here, and after we will resume from here for the next class, if that is fine by you. So anybody has a different opinion? Any different opinion? Nobody has a different opinion. All right. So if you are there, write present in the chat, write here in the chat, write something in the chat now, and I will stop the class in 1 minute. I'm waiting for 1 minute. Write present in the chat. Okay. All right. Onur has written. Write present in the chat in 1 minute. This is 10:03. By 10:04, I will stop the recording. It means you were not in the class if you could not hear me and write in 1 minute. You just have to write here. So if you can't write here in 1 minute, you probably were outside drinking chai. You were not in class. Okay, I'm still waiting for those who want to write. I'm waiting. I'll wait till 10:04 and I'll stop.